Jo sí, ja pots entrar. No, espera.
Què passa aquí?
Parla?
Hola.
Sí?
Sí? Ah.
Hello, everyone.
Hello.
Parla tu, Cari.
Hola. Hi. Hello. Hello, Marie. Hello. Marie.
Hello.
Hello.
Hello, Cari. Parla tu, que sortis davant.
Hola. Sí? Ja parlo. Surto?
Ara sí.
Vale. Hello. Un moment. Hello, morning. Okay. Vale. Com ho tens? Va. Hello, morning. Aquí. Sí. Hello.
Hi.
Hi.
Hello, everybody.
Hello.
Hello. How are you? The sound is okay today? Yes.
Or not?
Yes. Perfect. Welcome again to our online workshop. We have talked on the previous sessions about the bodies, the glaze composition, how to mix the glaze, how to apply frites, and now you know that just one different thing can give different results. Today we will talk about firing shadows and crystal shapes. Yes, it's very important.
Yeah.
Okay.
In the same glaze, different firing shadow.
For some reason, the Zoom signal. But the name that doesn't matter if it's not your name. Don't worry.
No worry.
Thanks to tell us. Now we will show you different pieces with different crystal shapes. Yeah, and later we will talk about it with a PowerPoint presentation. Yeah.
Okay. It's a camera. Okay. Look, this is a opaque glaze. The recipe is Peter Isley recipe. It's titanium, cobalt, and manganese. Look, the crystals are very wrong. Wrong. Huh? This one, this is a cobalt glaze, cobalt carbonate and cobalt oxide. You can see the shape is special. And this is the same composition. But in this pot, in this glaze, the first hole are more in low temperature, 1050 degrees Celsius. Okay, in this one is more higher, and this one is the firing is was in the gas kiln.
It's oxidation. Both pieces are in oxidation firings, but this one in a gas kiln and this one in electric kiln.
What happened? you will have different results, but the atmosphere is not the same. This is neutral, and this is oxygen with oxygen. You know, in the gas kiln there is a combustion. Okay, it's the crystal for grow. The crystal need oxygen. If you don't have too much oxygen in the kiln, the crystal grow with the stress. You know, the form is different. Okay.
And later with a PowerPoint, we will show you.
Yes.
the
This
temperatures.
is in the gas kiln too. The crystals are like a star. Okay, you can see are different. Sometimes you can touch the crystals. They
Three-dimensional.
yeah. This is another thing. Very small secondary crystals. Okay, many different. You can see the colors.
And you can see different halos.
Yes, this is another thing. We talk about this. This one is another. Many secondary crystals too. And this one too, another secondary crystals too. I will talk about different options you can get. Okay.
Yes, because you can decide
The
the
size.
shape of the crystal you are looking for. You can choose. Then crystalline is not only to get crystals, it's more of this. Is to decide the type of crystal.
Yes. For example, you can get the just the primary and no secondary. And this one you can see many different. Okay. I will talk about it as a moment, but might have a problem with the another thing. This pot is stoneware. I talked about this yesterday on no glaze inside, and look what happened. It's broken. I don't know what is the crack. Look, this part. You can see. You must put, if you use a stoneware, glaze inside. Okay, if not, this is my my first pots many times ago. Okay.
Yeah.
Okay. I will show you the PowerPoint. A moment. Okay. Now. Yes, crystal shapes. This crystal, for example, is a crystal in the gas kiln.
This in a gas kiln is crystalline and reduction in a very high temperature. We will talk about it another day. Yeah. Okay. Crystalline glaze. The basic composition is silica, crystal former, and fluxes. Yeah. Why we talk about crystal formers? Because now this workshop is about zinc oxide crystals, but you can work with iron crystals, molybdenum crystals, or manganese crystals. Yeah, but here this workshop just zinc oxide. Yeah, then silica, zinc oxide, and the fluxes. Yeah, the fluxes lower the melting temperature of the glaze. And the glaze must be fluid enough to form the crystals. Then the firing schedule is very important, the peak temperature.
Yes, and the time you get this temperature, what happens? For example, forget the con 10, for example, if you spend 6 hours, the glazes will be more clean. The background clean, the crystal, more crystal is more beautiful. Why?
There no interact the clay and the glaze. Yeah.
But
then it's important to get the peak temperature fast. But if your kiln is old or your kiln can go to 1270, you can modify it. For example, you can go in 6 or 7 hours to 1270 and hold there 15 minutes. Or if it's not possible with your kiln, maybe you can go to 1260 or 1265
or
And
100
then-
to 140.
yeah, and hold there 20 minutes. Yeah. Another way is to increase the flux.
For example, for people asked about con 6.
Yeah. To fire at con 6, you must increase the flux, adding lithium, magnesium, strontium, or lepidolite to your recipes, about 1 or 2%. You must try. If it
Okay.
works with 1% or 1.5% or 2%, you must try. We can't give you exactly.
What happens here? You can see the lithium. You can put maybe for con 6, 3%. Okay, but some materials are very fluid in low amounts, like a magnesium. If you put 1% of magnesium, is more fluid the glaze. If you put 5%, will be refractory. Do you know? Be careful. The lithium is more lithium, more fluid. But some materials in low amounts are fluid, and big amounts are refractory. Be careful. Okay, and maybe change the color of the crystal, the glaze. Maybe it will be matte glaze. If you put a lot.
For that, we recommend to use between 1 and 2%.
Yeah. Lepidolite, what happened with lepidolite? Lepidolite is like a lithium, but cheaper. Very cheap. Okay. I use a lot of lepidolite.
Yeah. And in the other way, if the glaze is too much fluid,
Yeah. For example,
then,
with
manganese recipes sometimes are very fluid. Yeah. And how you can see that? You can see that because you haven't got crystals. The crystals are all in the collector and the pedestal. If you see crystals in the collector or in the bottom of the piece, but there aren't crystals in the top, is because it's too much fluid. Then you can decrease the flux adding alumina between 1 or 2%.
For more flux, you have different options, more options, these ones. And for less flux, you have
only
just
alumina.
Okay. No.
Here is just a periodic table of the ceramic oxides. Yeah, is because here is very clear. Yeah, you can see the flux.
Look, alkaline flux. You have here alkaline flux.
I think somebody has the microphone open. Please close.
Please, yes, but
Thank you.
Okay, this is alkaline flux. More fluxes. This is a colorants. These ones. Crystal formers. These ones. Okay, and these one are super fluxes. The bismuth is super flux. The lead is super flux, and the tin oxide is super flux.
And you must know that, because sometimes maybe you are working with bismuth and you say, oh, wow, no crystals. What happens? It's because it's very fluid. Yeah.
Super flux. Okay. Because
it's important then to know the materials you are using in your glazes, and then how to modify the firing schedule to get nice crystals. Yeah.
Okay.
Here, two examples or two firing schedules. It's nothing important, but just to see. The red one is the faster one. Yeah, you see. But both arrive at the same temperature, but one is faster than the other.
What happens? You can get this temperature in 6 hours. The glaze you do translucent glaze will be more white, homogeneous color, very white. If you use this one, you can
take more temperature to go.
Maybe milking some parts, and the color is not too much nice. Be careful, but this is for the time.
And the only difference you can see, the only difference is the time to go to the peak temperature. The other part of the firing schedule is the same, but only this gives very different results. Yeah, this is important. Yeah. Okay. In the it's important to talk about the uncolored glaze produce the most nuclei and rutile sometimes less amount of nuclei.
What happens? Sometimes if you want you want to do one translucent glaze and you don't put
any oxides for the colors. You decide just white.
Many times problems in the top of the piece in the fillers.
Yeah, or in the bowls or in the plates.
Many in
the border, yeah, or
the border or the board, you have many problems. Okay.
Too much crystals, maybe.
You can put 3% of titanium in this glaze. The color don't change and no problems.
Yeah.
Okay. What?
Then, from the peak temperature to the soaking temperature, that means from the peak to the first hold. Yeah. You know that to create halos and to have crystals, you must hold the temperature to give enough time to grow the crystals. Yeah. Then from the peak temperature to the first hold, you need to spend minimum 45 minutes. This is important.
The clay need time for close the porosity of the clay. If not, if the kiln go down very fast, what happens? The clay, the porosity is open, and the glaze in the clay
interact.
Okay.
Yeah. Fast firings produce more crystals because it cuts down the absorption of alumina and other materials from the clay body. Yeah. And alumina prevents crystallization because it increases the viscosity of the melted glaze, and which inhibits crystal growth. Yeah. This is important to control.
We say it, but in the electric kilns, no problem. But all the kilns spend 45 minutes.
More or less.
If you use a gas kiln, you have the chimney for the smoke, but you have combustion. But you must close the chimney when you get the peak temperature. You must close. When you get this temperature, you must close to this temperature. Okay. Here. Okay.
Closing the chimney. Yeah.
You have this here. Okay. Yeah. Sorry. See?
Yeah. This is important.
It's important. This. Yeah.
In the electric kilns, usually all the kilns spend more or less 45 minutes. That is not important. But in oxidation firings, in gas kilns, you must control. Yeah.
Okay. Well,
here, varying the temperature during holding produce halos or bands. Yeah. Then different temperatures give different halos. Yeah, and it's possible to control and design the crystal shapes. Here you can see different crystals. Yes.
Yeah. Yes. This one in the background. See that this are no crystals, eh?
Yeah. This is the both in the center and this one.
The small one is iron. It's like a oil spot.
Yeah, similar. Yeah.
Okay. It's a change of molecular of the iron.
Yeah, okay. But not secondary crystals.
No secondary. It's another thing.
Then the crystals can grow more or less between 1,140 degrees and 800 degrees. The firing schedule has a large effect on the characteristics of the crystal that form. At the top of the crystal growing temperature range, later you can see the pictures. This picture A, yeah, it's like yeah, and then on the low end produce like round crystals, like spheric crystals. Yeah, it's picture B.
This temperature,
and yeah,
you can get
secondary crystals.
Why? The glaze is very viscose. It's not fluid, and later appear many different special crystals. Okay.
Yeah. And then sometimes say, oh, I'm doing the recipe of the galaxy, but no secondary crystals. Maybe you are not doing the correct firing schedule. But we will talk about galaxy glaze on Wednesday.
Okay.
Here are the pictures. The first one is crystal format at 1,110. You can see the shape. And the other one at 1,040. Yeah.
Okay. Usually in more low temperature, the crystal grow more, but the glaze is what happened here. When more temperature is more is the same. No, it's more energy. The the molecules travel very
The
fast.
ions travel very fast and then are repelled, yeah, with the.
It's for it. This is for, you know, but
It's for,
repelled.
yeah.
Okay, and here the glaze is more fluid, less
And
fluid,
the ions are traveling slowly, yeah.
and grow more fast. Okay, they're different.
Then the first hold temperature is the most important. This one determines the shape of the crystal. You must decide with the temperature if you find a star crystal or a flower or round crystal. Yeah? The soaking or holding time of this first stop is very important too, because there are only available one amount of zinc to create the crystals. And if you spend, for example, 6 hours at the first holding temperature, maybe later you hasn't got more zinc to create alloys or to create secondary crystals.
Yeah.
There are just
You have
one amount.
Don't think if you spend in the first hold and later.
It's like money. If you have $1,000, if you buy something for $1,000, then you can buy nothing else. Yeah? Then it's the same. You must decide, and you must work with the temperatures. Yeah?
Okay, yeah. This is in the gas kiln. In the gas kiln, the crystal are like a star, but the atmosphere is important
but
too.
Here you can see
here,
the shape.
The shape, I stay 40 minutes, and 1080 is for this part of the crystals. And now all the crystals is like a star. Why? It's this part is the first one, is the most important. 40 minutes, and later you have. Okay.
Yeah, and then you can decide if you would like to have 1 allo, 2, 3, 4. That depends of the firing schedule. Yeah.
Okay. Another.
Here another one.
The first one is more time. I think 4 hours.
Yeah, but at 1,000.
100, and this is the second one. Okay. This one, 1,050. But look, it's like a ring. It's a ring, but
yeah,
the first one is very important. Okay. Another one. This is more lower. The first one.
Lower temperature, and then going up, and then down again. You can do that. You can start down, then go up, then down, up. Yeah, you can play with that. The glaze composition, as you know, not only the alloys are formed with temperatures. Some alloys are formed with the glaze composition. Yeah, as you have seen on the first the first recipes and firing schedules Jose showed to you, one piece of copper, yeah, with not a very complicated firing schedule, and has a lot of alloys, many alloys.
If you want a secondary crystal, the copper is the best one.
Yeah, it's just to know. You can control, but not all.
But some materials you can get different structures too. For example, with the manganese, usually the crystals are more round, and nickel, for example, I like stars.
Yeah.
Stars.
And at the different temperatures, change the color of the. Using the same metallic oxide, maybe is from gold to silver. It depends. Yeah, it depends, but at different temperatures change a little bit. Yeah. Then the RAM cool down. In electric firing, must be natural cool. That can take between 12 and 20 hours. It depends on the kiln. And never open the kiln up of 80 degrees. In gas reduction firings, it's better to open the chimney for cool down fast, just to 700 degrees.
Later you can close, but
Yeah, and then natural cool to room temperature. Yeah,
Why?
it's because if not, the piece can reoxidize. Yeah, but this is only with gas reduction firings. Okay. Then different kinds of kilns give different temperatures.
My
Here,
kilns are the fiber. What happened? In this kiln, you must put, well, yes, you can see. The temperature is homogeneous.
yeah, there are the temperatures divided with the bricks and the pieces. And in a fiber kiln, not. All the temperature is in the pieces.
Yeah.
Then different kilns give different results. Yeah.
My kilns are fiber kilns,
but doesn't matter. You can work with both. Yeah, it's just to explain one different thing gives different results. The kiln atmosphere too. The kiln atmosphere affect the crystal grow in the glaze. Yeah, and you know there are oxidation firing, neutral atmosphere, and reduction firing. Jose has explained it to you a little bit. Yeah. Then clay bodies. While the glaze composition and firing schedule are the most important factors to consider, the clay body are very important. You know that these can diffuse into the glaze at high firing temperatures. Yeah. Then if you use porcelain, you have most white and lighter clay bodies will not interact with the crystal grow. Yeah, it's for that we always say it's better.
usually with the stoneware we have more milky glazes in some parts.
Yeah, or change the color. Maybe you are looking for a white that is not white, it's like cream or like
Yeah,
different.
it's for the both, but for some glazes it's better stoneware.
Yeah. You can work with both, but you must know why. Here is just to show you different clays. Yeah, then earthenware. Yeah, you know the maximum temperature is 1,200, and stoneware sometimes 1,300, and more temperature for some porcelains. Yeah, then all the clays interact with the glaze.
Okay, now
we will show you different examples of firing schedules.
some questions. Yes. Ok. Preguntarles si están aquí, porque no sé si están aquí. Ok.
The firing is about the shape of the crystals you are looking for, and then if you are looking to create halos or not.
Look, this one is for the galaxy. Okay.
This one is an example of the galaxy.
Look, many rings. Okay. What is important in this firing schedule is in high temperature is very Conti 12.
Yeah.
Con 12, and later very short.
Very short holds. Yeah.
Okay.
Here to get this.
Yeah.
This one is electric. Yeah, electric oxidation firing. You can do with you can see.
Sí.
You can see here the temperatures, here the time, hold minutes, and here the atmosphere, then oxidation. Yeah. And here I show you others, and you can see the same. It's just to follow this. Yeah. This one, yes. This one, yes, is 1,280. Yeah.
Okay. You can put lithium.
You can add lithium and decrease the temperature. Now you know.
This is very important. The shores holding, but if you spend all the zinc, all the amount of zinc
on the first one, then you can get secondary.
And this one is very important too. Okay, this one is very important too for the secondary crystals. Okay, no, I'm sorry. sorry.
Yeah, here another one, just to show you, it's the same. You have the temperatures, the time, hold minutes, and atmosphere. This one is oxidation too. Another one.
This is in reduction.
This is gas kiln reduction firing. Yeah, but we will talk about this, and we will spend one day. But it's just to show you different firings, different results. Yeah. Here's another one. It's the same. It's a firing schedule in gas kiln reduction firing. You can see one part is oxidation, and another is reduction.
Okay, this is important.
Yeah.
What happened with these glazes? If you use these glazes without reduction, will be white glazes. But
yeah, you can use too. Yeah.
This is another.
Here another one.
Yeah, yes. This is nice.
Yeah. This is more simple. Less halos, less variation of temperatures. One day we will talk about the gas kiln. Yes.
Yes, but I don't have.
But this is a hand control. We haven't got a controller for our gas kiln.
No.
We have only a controller for our electric kiln, not for the gas. Yeah, but we will talk about it. Yeah. Here another one.
This is very interesting. But look, this is the crystal, and this is the halo. Very big halo.
Big halo is because 2 hours. You can see. Nice. 2 hours, then big halo. Yeah.
Okay, but I talk about this. Too hot, the crystal like a star, but don't grow too much. But too much energy in the glaze.
Yeah.
Here the glaze is more viscous.
And then if you spend 2 hours, you have a big halo there. Yeah. And here's another one.
Opposite. The first one, the first stop keep is in low temperature, 1050, 50. And later the crystal is very round. You can see. Different. I don't like too much these crystals, but
just modifying all the firing, you modify all the results.
Yeah. Okay, here another. Sí.
Okay. Yeah. Here another one in oxidation too. Yeah.
This is with cobalt.
And here is one is interesting.
If you want to get secondary crystals with nickel, it's opposite. Usually all the glazes in low temperature you can get secondary, but with the nickel is opposite in high. 1120 you can get special crystals, very special. But the picture is not the best. These ones. Okay. It's all.
Okay, now we will do a demo.
Yes.
Okay, somebody asked if it's possible to control where the crystal grow. Yeah. We will talk about zincite and seeding. Yeah. Here I show you. This is a mineral. Zincite. I will send you information about where you can buy it in eBay, Amazon, or ask to your supplier maybe. Yeah?
The most easy for use. One phone. You can see. Okay, you must.
Yeah, you have like this, different colors. Sometimes white, sometimes amber. Yeah.
Yeah.
Put here and broken. Yeah, and then you can use, but must be like powder. I will send you is zincite.
Zincite.
But I will send you with the video of today. I will send you more information where you can buy it. Okay.
Okay. What happens? There's many colors, but these ones are not natural crystals. This one is making artificial.
Yeah.
It's making in Poland, and these parts are the rest. they take the big crystals and this one is so they
But-
sell this
But
very
to do
cheap.
that, you don't need
Is
nothing special.
If you want buy one crystal nice, it's very expensive. Okay, you must broken very small, very small. This is too big. You must take the small ones. Okay, and look, this is a body, porcelain body,
Porcelain body, no biscuit.
no biscuit.
Okay,
No
Like-
biscuit. And now, a little of water. Un agujero.
small hole here, yeah.
What? It's not.
Okay, yeah, small hole. As well, as well.
More easy.
Yeah,
Okay,
small
and now
hole.
look,
And now,
pen, water, and now, oops,
okay,
you can take.
yeah, you get it, and you put,
And press.
Yeah.
Inside the clay, and now it's inside, huh? Look, it's inside.
yeah, it's difficult with the camera, I'm sorry, but it's inside, yeah?
And you must close a little. What happens? If you put, you can put one here, another here, another here. 3 is okay. What happens? If you put the zinc side in the glaze go down and the zinc side go down. If you
Yeah.
put the zinc side here, maybe the crystal will grow.
Do you understand why Jose is using
In the
now,
body,
in the body and not in the glaze? Because if you put in the glaze, when the glaze are very fluid, go down and the crystal too, yeah? But now it's inserted inside and then don't move, it's here, yeah? And
Yeah.
what it works?
Another.
A leather hard body, yes, yes. Or a little more drier than a leather hard, yeah.
Look,
But not biscuit, yeah?
no biscuit, no. Look, here, it's here.
It's here. It's
It's-
difficult
the
with the
camera
camera,
is-
sorry,
Yeah.
but it's here, yeah? Then it works like a imán, like a magnetic, yeah?
Yes, look like a magnetic. What happens? This crystal will grow more fast, and usually sometimes you can get different crystals. I don't use too much, but if you use this, you must use this in darker colors. Why? This will be no se disuelve.
Yeah, it's not dissolved. Then you can see there are something there.
Okay.
And
If you
it's
use-
not very nice
If
if
you
you're
use-
using white
or
or
with iron,
very clear.
you can see
Yeah.
the
Usually Jose don't use. He use maybe sometimes in plates.
yes, the plate is more. You can see, but you have the thickness is
Yeah.
more thick. You know, maybe you have one plate, you can put one here, another here, another here. I'm sure you will
The-
have crystals,
The crystals grow everywhere,
but this
yeah,
one,
but this one's bigger. Then you can decide, I like one bigger crystal here and another one there, yeah?
maybe you will have less crystals.
Less, yeah, sure.
Why? But you have one amount of zinc.
Yeah,
It's one crystal.
grow a lot, then others can grow, yeah? But we recommend this only
In the plates.
in plates. Why? Because sometimes you do a plate and all the crystals are here or all the crystals are there. And to have a nice plate,
You can put 1, 2, 3. I'm sure you have crystals on the plate.
other crystal stimulators, no.
No.
No, we doesn't know others, no. Just
the zinc.
zinc. Then zincite is a mineral of zinc, yeah, but no. A collector in the plates, it depends, but we will talk. This one is not necessary, you see, no glazed,
Well,
just a little bit, but no, yeah, then no. It depends of the shape of your plates. Sometimes it's not necessary, yeah? But here you can decide if you would like a crystal here, there, and then are nicer. Because sometimes you can have problems with the plates. Yeah?
What happens? If you have one pot like this, it's a big pot, usually no problem. You can get crystals,
Everywhere.
but if you have a small pot, it's more difficult to get crystals. But sometimes go down.